Okay, here we go with section 2.3, polynomial division. I guess what we need to remember here is how we deal with long division first, right? Now, an example of long division could be simply if you are dividing, say, 3 into 145. Now, I hope you remember the process. We look at the first number here, or this number here, and we look at this number here. Does 3 go into 1? You say no. So you got to go to the next one. Does 3 go into 14? Absolutely. It goes 4 times. 4 times 3 is 12, right? And then we subtract. The 14 minus 12 gives me 2, right? And then, sorry, I was thinking about something. And you bring this 5 down, boom, 3 goes into 25. How many times, right? It goes 8 times. That would be 8 times 3 is 24. You have a remainder of 1 because 3 no longer can fit into this number and there's nothing else to do. So this is an example of long division. And one way to write this would be 3 times 48 plus 1 is equal to 145, right? So this is sort of a division statement. What I'd like you to remember is these words here, right? So the divisor is what goes in, so the 3 is a divisor. The dividend is what you're breaking down here, so the dividend is 148. The quotient is always an answer to your division up top here, and the remainder is what you have at the bottom. Now, if this happened to have no remainder, then the divisor ends up being a factor of the dividend. And that is essentially what we're looking here for. Okay? We're going to be dealing with polynomials, however, more difficult questions, okay? We're going to be looking at situations, for example, if I'm asking you to divide x minus 1 into something like x squared plus 7x minus 8. Now, if I gave you x squared plus 7x minus 8 and asked you to factor it, I'm hoping you'd be able to come up with the factors for this thing. Now, let's look at polynomial division here, and we'll try and see how we can equate these two. So the process is the same. Look at the x. What do you have to multiply it by to get the x squared? Hopefully you can see that it's just x, right? So x times this whole thing now would be x squared minus x. And we subtract just like before. These disappear. 7 minus a minus is a plus, so I have 8x minus 8. X times 8 now would give me, and then we would give me 8x, and then you multiply the 8 by the whole thing, so it'd be 8x minus 8. Hopefully you can see that after subtraction here, you would have a remainder of 0, right? Which means that this is my other factor. It means that if you have this polynomial and or this trinomial or quadratic, and I asked you to factor it, hopefully you would have the skills to do it in this way without the long division. However, I'm trying to show you that it's the same thing, kind of, okay? Or they work together. They're different ways of doing the same thing. And again, what this means is that you'd have x squared plus 7x minus 8 is equal to x minus 1 times x plus 8, right? So what would happen, say, if I change this up a little bit? Let's look at x minus 1, and let's put it into x squared plus 7x. Let's change this and call it a plus 1. Now, I mentioned that if your remainder is 0, it means that this is a factor. And indeed, we saw that it was a factor when we factored it like we have in the past, broken it down into binomials, okay? No remainder, they go in evenly. When you FOIL these out, boom, you get exactly that. Well, what happens in a situation where they're not a factor? Let's do the same thing here. X times x would give me x squared minus x. Now I subtract. 7 minus a minus would be 8x. I have plus 1. 8 times x would give me 8x, so I put an 8 up here. Multiply this times the whole binomial, you get 8x minus 8. Now, when we subtract, that goes away. 1 minus a minus is a plus, so that becomes a remainder of 9. So now I can safely say that x minus 1 is not a factor of that quadratic that is inside, that is the dividend, right? So how would we write this out? Well, we can say that x squared plus 7x plus 1 is equal to the divisor, right, times the quotient, but then I have a remainder of 9. So what I do is I just add 9 at the end. This provides me with a little bit of information. The remainder can be useful at times. But for right now, what we're trying to do is see if things are factors. Now, these are quadratics, second degree polynomial functions. We are looking at cubic ones as well, okay? They get significantly more complicated, and we are going to look at a couple of these, all right? So let me just have a fresh sheet of paper here. I'll start with a fresh sheet, and we'll look at a couple here. So let's have a look. I want to divide x minus 2 into a longer polynomial here, 6x cubed minus 19x squared plus 11x plus 6. So let's see if this is a factor of that. And in order for it to be a factor, the remainder will have to be 0. So we've got to do the long division. X times what gives me 6x cubed. Hopefully you can see that it's 6x squared. Now whatever you put up here, you multiply by the whole binomial. So 6x cubed minus 12x squared, and we subtract like we have in the past. So that disappears. Negative 19 minus a minus is a plus, so I end up with negative 7x squared. Let's bring that bad boy down, and we got 11x. Now x times negative 7x gives me negative 7x squared. You multiply by the other one as well, that's plus 14x. Now I'm subtracting, disappears, 11 minus 14, negative 3x, boom, plus 6. X times negative 3 gives me negative 3x minus 6, or sorry, plus 6, that's good. So I end up with a remainder of 0, which means that 6x cubed minus 19x squared plus 11x plus 6 is equal to this binomial here times this quotient here. Now you've almost broken it down into its full factored form. What we need to do now, however, is look at this quadratic here and see if we can break that down any further. Try to factor it. Give it a shot before I give you the answer. I'm going to check it out here. 3x and then 3 and a 1, and that's going to be a minus, and that's going to be a plus. So here are your 3 factors. This third degree polynomial function factors into these 3 binomials. What can you get from these 3 binomials? We've talked about graphing these cubic functions. You know what they look like. You just need to find the x-intercepts, and the x-intercepts are your solutions, and the solutions are found from the factors. So right away you can tell me that x is 2, x is 3 halves, and x is negative 1/3. These are your solutions. You know it's positive, you know it starts down here, you can figure out the x-intercepts, and we've got more information to graph these polynomial functions. Okay? Now, let's take it another step further here. Let's look at another example. If I have x minus 2 going into, let's say, 3x cubed minus 2x squared plus 1. Well, maybe you see that there's a problem here. And there will be a problem when you start doing the division, because what you are missing here is an x value. You will have difficulty doing this long division if you do not have something for every term in a polynomial, which means that if there is no x, you put a 0x and then put the plus 1 on the outside. You have to fill in this space. You have to have something to represent nothing, and that would be 0x, okay? Now, so x times 3x squared would give me 3x cubed, and then minus 6x squared, right? Subtract, gone, that gives me 4x squared plus 0x, so x times 4x would give me 4x squared minus 8x. Subtracting again, those disappeared. I have 8x plus 1. 8 times x would give me 8x. And here I have a minus 16. So what you have now is 1 minus a minus. That gives me a remainder of 17. So this binomial here is not a factor of that cubic function. Okay, so there's not really much else we can do. I can write it down in division notation, or whatever you want to call it, let's just put the plus 1. If you want to put the 0x, that's fine. But that's equal to x minus 2, the divisor, times the quotient. But it didn't go in evenly, so I have a remainder. And boom, there you have long division. Okay? There is another way to do long division. That, however, is called synthetic division. I'd be happy to look at that. I'll probably make another video for that one. But before we move on, I actually want to do one last one here, okay? I'm going to ask you to divide x squared minus 2x plus 3 into a longer one. 3x to the power of 4 plus 2x cubed minus 5x squared plus 2x minus 1. So we've got a trinomial now that's going into a quartic function, okay? But we still look at the first terms and the first terms. X squared times what would give me this? Hopefully you can see that it's going to be a 3x squared. So I put it above the square. And then we multiply this term by the whole thing. That's going to give me 3x to the power of 4 minus 6x cubed plus 9x squared. And then we do our subtractions. Gone. 2 minus a minus gives me 8x cubed. Minus 5 minus 9 is negative 14x squared. Let's bring another one down. 2x. Okay? Now, x times what? It looks like 8x to me. So plus 8x would give me 8x cubed, right? Now we have to multiply by the other terms. Negative 16x squared plus 24x. Now, that disappears. Minus 14, that gives me 2x squared. 2 minus 24 is negative 22x. Let's bring the minus 1 down. And we keep going until there's nothing else that I can do. X squared times 2 gives me 2x squared. And then the 2 times the negative 2x is negative 4x. And the 2 times the 3 gives me the 6. I subtract, disappears. Negative 22 minus a minus is a plus, so it's negative 18x. Minus 1 minus 6 minus 7. That is my remainder, since x squared will no longer go into here at all. So now it means that this times this plus this is equal to that. And it's a long drawn out statement. I can write it down for you if you like. X squared minus, so hold on here, x squared minus 2x plus 3 times my 3x squared plus 8x plus 2 plus the remainder, which is negative 18x minus 7, is equal to this entire bad boy on the inside. Ladies and gentlemen, the only thing that you can do with this is practice your long division. I would be happy to help you with this, okay? Notice the patterns. As soon as you find the patterns, you'll find it easier to do. I will make another video with synthetic division, which some people find easier. There are, however, a few other steps that you need to remember with synthetic division.